All right, so had to stop recording after number 17. So we'll pick up here with number 18. We got piecewise. Notice the interval that's talking about. The breakpoint is -2. We have less than or equal to -2 and greater than -2. So if you think about the x-axis as a number line, -2 would be right here, but now we expand into two-dimensional. We've got that vertical line there. You don't really need to put this. I'm just putting it on there to help us see the two intervals. We've got everything to the left of -2, and we have everything to the right of -2. When we're to the left of -2, when we're less than or equal to -2, we use the equation x plus 2. It's nice to know the endpoint. So if I take this -2 and plug it in to that equation, I get -2 plus 2, which is 0. So the endpoint, the far right endpoint is -2, 0. Since it's equal to, that is a closed circle. So I'm going to go ahead and do a closed circle at -2. Now I want to work backwards. If you want to do your slope of 1 over 1, understand you're working backwards. Instead of going up 1 over 1, we go down 1, back 1. You can do that. Or if you want to test another point, you could plug in like -3, for example. -3 plus 2 is -1. So either way, whether we go down 1, back 1, or we plug in -3 and get the point, we get that point right there. If I continue it on down forever, there's that line. Then the second interval happens when we start at -2 and move to the right. It'd be nice to know the endpoint here. So take that -2, plug it into this equation. 3 times -2 would be -6. Now this is an open circle because it's not equal to. So I'm going to go to -2, -6, put an open circle there. And now we move to the right. So we can do the slope of up 3 over 1 if you'd like. Count up 3 over 1. If you want to plug in a point, you could plug in -1. 3 times -1 is -3. Either way, we end up going up 3 over 1, or the order pair -1, -3. You could continue that slope if you wanted to, giving us that. So there's that entire graph. Moving on to number 19. Now we've got 3 intervals. The first one is when we're less than 0. So let's plug 0 in to get an ordered pair. We end up with 0, 2. Oh, sorry, I got a little ahead of myself. I just put a closed circle there. We should have an open circle at 0, 2. And now I want to work backwards. It is a slope of 1. So if I work to the left, I go down 1, back 1. Or once again, you could plug in another order pair, like plug in -1. -1 plus 2 is 1, so we get -1, 1. We get that same order pair, and you can continue that. And you could plot as many of these points as you want. Travels on forever to the left. Now I plug in 0. For the second interval, I'll plug it into this equation. 2 times 0 plus 5 is 5, so I get the point 0, 5. This one's closed. So closed circle at 0, 5. And since it has another endpoint, 2, I'm going to go ahead and plug 2 in to get the far endpoint. 2 times 2 is 4, plus 5 is 9, so 2, 9. And then the one that one's a closed interval also. So closed circle and just connect the 2. That's the middle piece of that graph. Then we go 2. Let's plug that one into the third equation. -2 plus 1 is -1. So I get 2, -1. This is an open interval. And I can do my slope from there, which is really -1 over 1. So I go down 1, 1 to the right, down 1 to the right. Continue, and so we go on forever to the right with that slope. Or you could have plugged in 3. -3 plus 1 is -2. You get 3, -2. So you get the ordered pairs that help us get the 3 components. Now we do some graphing on number 20. It is an absolute value. If I want to make a table of values, normally we center around 0, but this has an h value. We always do the opposite sign. So instead of -2, I'm going to do a positive, which is my middle x value. And then I just surround this. So we can go 3, 4, and go 1, 0. Plug them in. Plug in 0. Order of operations. Make sure you don't neglect that. So when you plug it in, you do it says parentheses first. In this case, the grouping symbol is an absolute value. But do inside the absolute value first. 0 minus 2 is -2. So then I have the absolute value of -2, which is positive 2. So I have 1/2 times a positive 2 plus 4. Well, now you can do your multiplication. 1/2 times 2 is 1, plus 4 is 5. Plug 1 in. You're going to have 1 minus 2 in the absolute value, which is -1. Absolute value, that is positive 1. 1/2 times 1 is 1/2 plus 4. So we got 4.5. I'm going to have to write kind of small here. Plug in 2. 2 minus 2 is 0. absolute value of 0 is 0. 1/2 times 0 is 0. We end up with just the 4. And then you can plug in 3 and 4. It's symmetric. We're going to get 4.5 and we're going to get 5. Again, you can test them just to verify, but for sake of the video, I'm going to skip plugging them in and showing you that. So we end up with those 5 points, connect the dots for our absolute value, which should be a V shape. So you notice it got shifted to the right 2 and up 4. We went to the right 2 and up 4, and then it was compressed vertically because of that 1/2. So it's going up at half the rate it would have otherwise. Number 21, we see it's in standard form, so I might just find my x and y intercepts. So if I plug in 0 for y, I get, and we can pretend it's an equal sign when we do this, I get x equals -4, so an x-intercept of -4. When I plug in 0 for x, I get y as -4. So I have -4 and -4 for my intercepts. I can do open circles here, although the line is going to be open. That's the more important piece. So since it's not equal to, I can go ahead and do a dashed line. But then because it's an inequality, I need to shade, and I got to figure out where to shade. So we're going to test a point. Pick a point that's not on it. Like 0, 0 would be a nice point to test. Plug in 0 for x and 0 for y. So I go 0 plus 0 is greater than -4. Is that a true statement? Well, yes, it is. 0 is greater than -4. Therefore, 0, 0 is a solution. So everything that's on the same side of the line as 0, 0 is a solution. That's how inequalities work. Everything there is not, or is a solution. Everything over here is not a solution. So we just shade the side that has 0, 0 on it. Number 22, it's also in standard form. Same process. I'm going to find x and y intercepts. Plug in 0 for y, I get 3x equals 6, so x is 2. Plug in 0 for x, you get -2y equals 6, so we get -3. So 2, 0. We can go ahead and do closed circles this time. Looks like it went up 3 over 2. I can go up 3 over 2 to get another point. Solid line this time because it's equal to. And then one side contains solutions, one doesn't. So we're going to test a point. Let's test 0, 0 again. Plug it into the left side, you end up with 0. The right side, you end up with 6. Is 0 less than or equal to 6? Well, yes, it is. So 0, 0 is the solution. So everything on that same side is the solution. If it wasn't true, I would have shaded the other side. Now in this last section, we're identifying the type of function and describe transformation. So I see absolute value here. So that would be the type. We have a translation. We're going 5 to the right. So I'll say translation, right 5. I have a -a value, so it's going to reflect across the x-axis. And then I also have an a value of 1/3, so it's going to be compressed vertically. Next one, looks like it's going to be a quadratic. So it would be a parabola if you graphed it. It's shifting. We have a couple translations this time. So we're going to go up 3. And we go the opposite direction here of what we would think. So it's left 1. And that's all we've got for transformations on that one. Number 25, okay, I see in the picture it's absolute value. That's the type. Looks like it went down, so it's to be translated down 2. It didn't go left or right. And the slope, it's going up 1 over 1, so we don't have any sort of dilation. So we're good to go. This last one is quadratic. Translations, it went left 4. It went down 1. And everything else is okay. All right, that concludes the video.